In the late 1950s, a German pharmaceutical company released a new drug called thalidomide. It was marketed as a safe sedative, perfect for helping pregnant women with morning sickness. Doctors prescribed it enthusiastically, supposedly so safe that even overdoses weren't fatal. Then in 1961, doctors started noticing a horrifying pattern. Babies were being born with severe deformities, particularly focal where limbs are shortened or absent. Hands grew directly from the shoulders, feet emerged from the hip. In some cases, children had seal-like flippers instead of arms and legs. It took years to connect the deformities to thalidomide, because the idea that a medication could cause birth defects was relatively new. By the time it was pulled from the market, thalidomide had caused an estimated 10 to 20,000 birth defects worldwide, with thousands of infant deaths. The drug was never approved in the US, largely because of one FDA reviewer, Francis Altman Kelsey, who insisted on more safety data despite enormous pressure from pharmaceutical companies. Here's what makes it scientifically chilling. Thalidomide had been tested extensively on adult animals and humans. It appeared safe, but the testers never checked what it did to developing fetuses. The drug interferes with angiogenesis, the formation of blood vessels. In adults, this doesn't really matter much. In a developing embryo, it's catastrophic. Limbs don't form properly because blood vessels don't grow to supply them. The drug was safe for the people taking it and deadly for their babies. The philosophical issue here is about risk regulation and the precautionary principle. Before thalidomide, drug testing was relatively lax. This disaster led to modern pharmaceutical regulations requiring extensive testing, including on pregnant animals. But here's the question. How much testing is enough? We can never test for every possible outcome. We can never be 100% certain a drug is safe. Every new drug is a gamble. We do our best to minimize the risk, but we can never eliminate it entirely. The question is just whether we're honest about that, and whether we truly learn to balance innovation with caution, and that we recognize that the medication that we're using to treat various conditions are often also with risks themselves, and that we're taking that to measure them out. But whilst most medication and treatment is developed to deal with conditions or illnesses that would otherwise be worse for the individual, there is always an inherent risk that we need to make people aware of, and so that people need to be aware of so that they can be as informed as possible. And this is a scary side of science, and the key reason why we need science communication. And another spooky science episode. Please tune in tomorrow for another one.